Okay, so I'm going to talk about this assignment brief. This is WP1, Issues in Website Design. And I'm going to talk about, first of all, tasks 1. There's 3 tasks in total, but I'm going to start with task 1 and just go through some of the web architecture that we have here. Okay, so I'm just going to create a new whiteboard. Now this hopefully will mean that I can now flip back between what I've just seen there and what I can go through. And so the web architecture, let's get a pen, shall we? This is really looking at the hardware that makes up the system. So let's think about what we actually have access to. So we have this computer called a server. This is a computer that runs on the internet, sits on the internet, and that can connect to different styles of device. We might have a switch, there might be a router, might be a hub, and attached to the hub we might have a few client computers. And you have to have an understanding really of what the differences are between a server, a client, and what the switch, router and hub actually do, because they do different things. So the switch is a very, very simple device. It literally fires off the messages that get sent to it in all sorts of random directions to any pathway that it's got connected to it. So a switch might be connected to lots of other switches, other routers, all sorts of different things. And it literally just blasts them out in any direction. Doesn't actually have any intelligence whatsoever and doesn't know where it's sending it. It's just literally sending them out as it needs to, the messages coming from the server. Eventually it will hit a router. Now the router actually has a built-in table inside it, and it will look at the address that the message is being sent for and will try and head it towards that particular item. It might not be directly to that item, it might be to a router or a switch that's near that item, but it will try and send it through closer to where its destination point is. Eventually you might end up with a hub somewhere in your network. What a hub does is, instead of distributing the message to one of the different clients that is connected to it, it actually sends the same message to all the clients at the same time. So therefore computers on the system are getting lots and lots of messages constantly that they can just ignore, because they say, oh, it's not for me, I'm just going to ignore it. There are programs you can get like Wireshark, which mean that you can actually listen in to the communications that are going on between other computers and actually see what packets of information that there are. And that takes us to our next part, packets. Now a packet is what we like to call a small section of the entire message that we are producing. Okay, so say this is our message that we are going to send across the internet. It might be a request, say, for a website. Well, each packet is part of this message, but is cut up into pieces. And each packet will have a header to say where it's being sent to, it will say where it's from, and various other bits of information, as well as the data that actually make up what you're sending. And each of these packets will be fired off onto the network separately. And they may arrive in completely different orders than the way that they were sent. So 3 of 5 might get there first, 2 of 5, 4 of 5, 5 of 5, and 1 of 5. And the server is able to see how many packets there should be for this message and which packet number this is, so it can reassemble the packets completely as it needs to. So it could move the 3 there, it can move the 1 over here, and let's get rid of this. I don't know if I can actually get rid of on this tool or not. There we go. Let's move this one as well. 3, 4, there we go. So I've now got my packets in the right order. Now the system that this is using is something called TCP IP, which stands for Transmission Control Protocol, Internet Protocol. Every computer on the internet has an address, an IP address, and that says basically where to actually send the message to, or where it's come from. The TCP part of the situation of the is actually about the packets, keeping an eye on which packets have arrived, etc., and what order to actually put them in, the transmission control. What happens if one of the packets, say for example, gets lost, so 2 never arrives? Well, the computer that's received these packages can say, hold on, we've waited X amount of time, so many milliseconds, this packet hasn't arrived, so I'm going to go and ask the sender of these 4 other packets, can you please resend? Just turned off my own volume. And then packet 2 will be resent. So in this way, it's a very efficient way of controlling packets of information sent across the internet. We generally talk to the internet via something we call a browser. And it's just an application that can talk along a particular type of connection known as HTTP. HTTP stands for Hypertext Transport Protocol, and it's about sending information in a certain way. When you see web pages, they are hypertext pages, HTML, hypertext markup language, and they are sent through, along with some graphics, etc., through the HTTP process. There's a secure version which uses something called the Secure Socket Layer, or SSL, which can allow information to be sent encrypted between the browser and the server. Now, to connect to the internet though, you have to have something in the middle of both of these, something called the ISP, the Internet Service Provider, and they are the company that have a lot of the network that goes out into the internet, and they give you some form of connector. We normally call it a router or a hub, but actually it's more like a multifunctional device. It has what's called a modem, modulator, demodulator in it sometimes, and it will also have maybe a router or a hub built in. And it also will have probably a wireless access point. And then the ISP will actually connect you to the server, and the server will then connect back via the ISP directly to you. So there is like a middleman, if you like. The ISP is someone like Virgin Media, etc. There is a difference between the World Wide Web and the internet. The internet is actually the physical hardware of what makes up the network that goes across the entire world. The World Wide Web is a collection of multimedia pages that you view through a browser, talking via HTTP. So when you are playing an online game and you are connected via a different application, a game program, you are not using the World Wide Web, but you are using the internet. Also on here, as you can see, I've got to talk about DNS servers and SMTP. So let's just speak very briefly about a DNS server. DNS stands for Dynamic Name Server. Now, we've talked about IP addresses very briefly, but we don't really talk about IP addresses when we're trying to connect to a website. What we do is we go to an address. This gives you an example. This isn't really Google's IP address. I've just made it up off the top of my head. But what a dynamic name server does is when you've got a request and you say, I want to go to this web page, please, it actually goes to one of these dynamic name servers to find out what IP address that website exists on, and sends it back to your browser so your browser can connect directly to that particular server. Okay? There is a process that you can go through, which we're going to cover in a few moments when we get onto another task. So to understand what can actually influence the speed of an internet connection, we actually have to go through how the internet connection works. Okay? So here's my laptop. Then I've got my server, which is going to be Google. I've got my ISP. Probably got a switch or two. Let's just do a couple of connections. Okay. So, how do we actually send a message? Okay, so this is my server. I'm also going to have my DNS here as well. So my dynamic name server is another computer. And they're connected to different routers. Okay, so I want to go to Google. And what's actually going to happen is, I know the name of the website is Google. So I'm going to send a packet through my router to my ISP saying, I'd like to go to Google, please. Now the ISP has something that it calls a cache. And this cache actually has a list of really well-recognised websites that people have already been to that use the ISP. So it doesn't necessarily need to go to the DNS server. If someone else has been to Google, it already knows what this address is. So it then sends that message back and says, oh, it's this IP address. And now the computer will go, oh, okay, let's go to the IP address at that location to get that information. Server processes that information, then sends it back. Let's choose a web page maybe that it hasn't seen before. So let's think of abc.yzx, completely random made up email URL. So the router then takes it to the ISP. The ISP looks in its cache and it hasn't got abc.yzx. So it now knows it needs to send a message to the DNS server. So it goes to the switch. This time it actually goes via the router, which then pings to this router, which pings to the DNS server. DNS server says, oh yes, I know the IP address of that server, and so it sends it back, and when it gets to the ISP adds it into its cache before sending it back to the user. The user can now connect directly to the server using whatever path it needs to actually connect with and get the information from that website. So the faster your DNS server works and the more cached DNS information you've got at your ISP level, the faster the connection will actually be. If you want to make it super fast, you can actually, in the address bar of your browser, type in the IP address of a website directly, and it will actually skip anything and go straight to the actual server without needing to worry about the DNS or anything inside the ISP cache. It actually cuts out a single journey, which can make it a bit faster. The speed of your computer, the speed of your browser, can actually play an impact on how fast you can actually bring a page up on your screen. So how much RAM you've got, what process you've got, can actually have an effect on how quickly a web page can come up. Especially because modern web pages are 200-300 megs, sort of as a minimum size. The connection that it actually takes, the route that it takes through the internet to actually get to your server will change the amount of time. It might be a few milliseconds here and there, but it can make a big difference. So actually geographically how close the server is to the client can make a big difference as well. We're talking, as I say, milliseconds here. The server will make a difference. It has to process the request that comes into it. So depending on how fast the server is, depend on how good the actual server will perform. It might have only so much bandwidth. So the bandwidth that you have for your own internet connection, the speed of your internet connection, is also an issue for the server side. The server only has so much bandwidth as well. All of these different factors can obviously play a part. If the page has to be translated from a computer language, say ASP.NET, into HTML before it then gets sent through to you, that means that server-side processing has to be done. If there's JavaScript to process on the client side, that JavaScript processing has to be done before showing the page. So there's a number of factors that actually influence the speed of how a web page can get from your computer from a server, or to your computer from a server. that should be enough for you to go on with so far. Obviously, security risks and protection mechanisms. You can talk about the laws here with things like GDPR. You should be able to find a lot of information on things like that. But you can also mention things like firewalls here. A firewall blocks certain access to certain ports and actually can inspect the packets of information coming in to make sure the information should be correct. I'm going to send you the link to a YouTube video that could be quite useful as well here. That's called The Warriors of the Web, if you want to search for it. But it does explain the process of a web page loading up on a client quite nicely.